First View TV, your cutting-edge television station, interfacing Africa and the rest of the world with excellent documentaries, business news, investment opportunities, lifestyle, and much more. We're currently on YouTube, Instagram, and Facebook. You can also view while on the move at www.firstviewtv.tv. First View TV, changing the narrative.
I'm going to invite our next speaker, Engineer Olumide Odukale. Engineer Olumide Odukale is a seasoned architect with over 25 years practice experience from working as a young graduate architect and starting his own firm, Project Point Limited, in 2001, from where he has overseen a sizable body of work. Influences include contemporary art and design, music, African art, and culture. Currently the principal architect and managing director of Project Point Limited, Lagos, Nigeria, and holds professional certifications and qualification. He is a principal architect for the development of 50-hectare Sapphire Garden Estate, Awoyaya Ibejuleki, Lagos, and was in charge of the overall layout of the estate, design of the residential and services buildings. He's also worked on a 7th-floor block of high luxury flats in Kofua Bayomi Street, VI, Lagos. He's worked on luxury and high-end residents in locations such as Banana Island, Osborne Foreshore Estates services, and he's rendered numerous services, including the selection and coordination of offshore components and procurement. He's been involved in the remodeling of offices for British American Tobacco at Victoria Island, Lagos. He's also worked on remodeling works of procurement department offices for Guinness PLC, Ikeja. He's done remodeling of offices for FSDH Merchant Bank, Lagos. He has worked on several branch buildings for commercial banks from design to occupation. He holds a Master's of Science in Architecture, a Bachelor's of Science in Architecture, and he's also a member of Nigerian Institutes of Architects, as well as a member of Architects Registration Council of Nigeria. Ladies and gentlemen, I present to you Architect Olumide Odukale. Thank you very much, sir.
Thank you very much, Sean. Good afternoon, everybody. Thank you for this opportunity to deliver this paper at this time in our country. My topic is globally accepted design and planning standards for high-rise and complex structures. So I want to start by, first of all, defining what do we mean by high-rise structure or complex structure. These are any man-made or engineered structures like taller than 75 feet or 25 meters, and they can be for various purposes, offices, commercial purposes. Some of them are telecommunication towers are also to high-rise structures. Some were built out of pride and out of need or out of ego, just to prove a statement or to elevate the country where it's placed. Some are monuments like the Eiffel Tower, the pyramids, and various other, Statue of Liberty, and various others. Now, what makes a structure or a building complex is the nature and relationship of the various elements and components that make the building functional or workable. These elements will arise from and include the design form or shape of the structure, the foundation on which it will sit, which is a challenge as we have seen today, especially in Lagos where we have a lot of loose soil, the resistance to wind load and other lateral forces, the materials that are used, the efficiency of the building, mechanical and electrical services, and several other factors. Now, for the purposes of this presentation, I'll be discussing high-rise structures used as buildings. So specifically, I'll be talking about buildings. As we have said, and a few other speakers have said, I mean, a high-rise building is one that is of a certain height. Now, a high-rise building has become more usable or more popular because of elevators and with the advancement of technology. The discovery of the elevator has made it possible for people to move between various floors, to move goods and people between various floors. These are buildings with heights and also we also have to look at it from a fire and safety point of view. There are buildings which heights are beyond the reach of the firefighting equipment and can have serious impact on evacuation of occupants in emergency situations. A high-rise building is defined as a building with an upright floor located more than 75 feet above the lowest level of fire department vehicle access. Now, again, we can also talk about what sort of fire equipment we have in Nigeria. Because of the heights and numbers of the occupants, as I said, fire safety is a major consideration in the design of high-rise buildings. Now, we must also state that buildings taller than 40 floors are not necessarily defined as high-rise, they are defined as skyscrapers. What we have described earlier is shown in this image as regards fire access. Now, I want to go back and look at the history of high-rise buildings. How did they come about? Where did they start from? They date back as far as ancient Rome and the Roman Empire, where some of those high-rise buildings and towers were erected to defend cities. In a few examples are in Egypt and in San Gimignano in Italy. Now, some of these buildings at that time were made of wood and brick, so it was not uncommon to have failures in the structures in those structures. But like I said earlier, the discovery of the elevator and steel during the Industrial Revolution removed height limitations for this building. It was not possible to go much higher because we could frame the building with steel, which was a new material, which was not available for a long time. Several other social economic factors have contributed to the increase in the development of high-rise buildings. The increase in population density and the need to provide housing for that growing population. In the last, especially after the World War II, we've seen that there's been a global population explosion. Especially in Lagos now, we have seen what is happening with population increases in Lagos. The increase in land value in major cities and urban centers also after World War II. So there was a demand for land and the prices were going up. Then also, especially in North America, there was competition amongst corporations to outdo each other in the height of their office building. So it was a case of, the bigger my building, the stronger my company should be. And marketing campaigns also, especially in the 70s and early 80s, promoted the allure of living in the sky. So when you're up there, you have a good view, you're up away from everybody. So all this contributed to, helped in the promotion of high-rise buildings. Now like I said, with the several high-rise buildings now exceed 100 floors. That's not even uncommon anymore. Height is no longer the strong anymore. As we have seen, if you travel to various places, the highest building now, the tallest building now is one that is in Dubai, the Burj Khalifa, which many people did not even think could be built. It is about 800 and something meters, 828 meters. So this sort of buildings are now quite common to see. Now, what is the design process for this kind of building? Now, there are several factors that should be considered by architects and building designers when embarking on this design and planning of high-rise buildings. This will be consequential to the success of that final product. And they would include, and this was mentioned by the previous speaker, Mr. Okonjo, the permitted height regulations for such buildings in that location. What is the zoning for that location? This information is usually available through the local city planning office or gazette. and any restrictions therein, defined therein, must be complied with. The nature of the soil in that location. This will usually require a geotechnical investigation and analysis of the soil in which the foundation of the building will sit by a geotechnical engineer in order to determine the load-bearing capacity and other conditions of the soil, and therefore the foundation type to be used. Now, this is very important in a city where there's a lot of made-up ground. We hear this expression, oh, sandfield. So a lot of reclamation has been done. For instance, Parkview used to be a park, and it was quite swampy. That has been filled up. Even Banana Island was water, and it has been filled up. So it is very important in a city like Lagos that the soil, the nature of the soil is ascertained, and thereby the foundation type to be used is properly looked at. What is commonly referred to as the soil test is conducted, and it has now become a requirement by Lagos State for buildings of more than 2 floors. The design of the building structural elements based on a calculation of load to ensure its integrity and stability. The calculation is carried out by a registered structural engineer based on the design provided by the architect. The building should also be able to support its own weight and that of its occupants. So, I mean, again, that is the issue of the foundation and the framing of the building. Oftentimes, as Engineer Wale Ogundalu has said, failure is oftentimes a result of building failure is oftentimes a failure of the design itself. The building must also be able to withstand wind, load, and pressure. This might not be a large factor here, but in certain countries, there's a lot of wind pressure on tall buildings. Then also, when you're putting up a building, a tall building, a high-rise building, what will be the impact of that building on its locality, on its environment, on other surrounding buildings? An assessment of the impact of that building is usually required. And this will regard the scale of the building, the vistas when thereafter, once the building is done. Is it going to block any views? The airspace to other buildings will be required by the planning authority, especially when the site is constrained, and if neighboring structures like heritage buildings, listed buildings might be affected by the proposed building or by the construction that is planned. The proposed building must also, in the design, respect the character of the existing area and maintain the distinct identity of the place. So you can't be in a purely low-rise residential area and then you want to plunk in 15 floors, you know, against what obtained. Study is very, very important to be done. The mechanical, plumbing, and ventilation requirements for the building. Now, these are usually done for most buildings, small and large, but they are particularly important for high-rise buildings because of the large occupancy and the complexity of the network of these building services. Several of these services are also designed to achieve good efficiency for the building. Recently, in the last 10 years, the last decade, people have been talking about global climate change, sustainability, energy efficiency, and environmental friendliness are now designed into many buildings. LEED standards and certification are now commonly desired and are achieved. This is now also becoming quite, it's catching on in Nigeria, where the demand for this sort of buildings now. People want to save energy, people want to protect the planet, and why should my building use so much energy? Then also the building brand and the aesthetics. Every building of that nature has a client. The client's vision must be enhanced and projected by the building's design and choice of material for the interior and exterior of the building. And safety and comfort of the occupants must be built in through adequate natural and artificial lighting, ventilation, fire prevention and protection, as well as clearly defined fire escape points. Vehicular access, circulation, parking, as well as other factors that will enhance the safety and comfort must also be of utmost priority. A full complement of experienced building design consultants must be engaged on the project. A few of the previous speakers have spoken on this, to provide design solutions for all the factors listed above. This will include the architects who initiate the design concept, the structural engineers who design the building's foundation and frames, the MEP engineers for various services that make the building comfortable. Then oftentimes there are specialist consultants who handle several other aspects, like we have spoken of the soil engineer, fire safety and detection, egress, that is how to get out of the building, security, information and communications, etc. Large volumes of construction drawings and documents running into hundreds of pages are produced by the various consultants in order to obtain necessary planning permits and for the construction work. To embark on such a project without the involvement and participation of such a team is most often a recipe for failure. Now, it is not uncommon in this country for documentation, for people not to even consult not to engage consultants. Oftentimes, consultants are even seen as an additional cost to the project. So a lot of clients try to do without them. Oh, I don't need that extra cost. It's not just to do a design or just to do a drawing, but it goes far more than that, far deeper than that, as we have seen. Their input and their contribution is very, very crucial. Beyond preparing the various drawings and specifications for the building work, this team of consultants will also be further engaged to extend their services to the inspection of the construction work being done by the contractor on an agreed and frequent basis. This is the best practice. But sadly, we have heard of many projects that don't even have consultants involved. They don't engage the expertise. Oftentimes, it's because the developer doesn't see the benefits of paying the fees, or simply, I've done it before. I can do it myself. I've done it somewhere. Nothing happened. It can be done again. So they did 2 floors. Nothing happened. Oh, okay. I can do 6 floors. And then I can do 10 floors. Without necessarily having the required skills or without having the backing of the expertise of consultants. Also, sadly, the system has often shown a lack of will to even deal with those kind of situations where projects don't have consultants engaged. The system tends to look away, and sometimes there's no law that compels him or her to engage consultants. So again, we talk about regulation. What are we allowed to do? What can you do? What is not allowed? Now, what are design and planning standards? What are the standards that we're talking about? These are sets of guidelines that have been defined by regulations over time, and they must be adhered to in the construction of the building. These guidelines are in place to ultimately allow for the optimal integrity of the building, safety and comfort of the user. In defining, now what happens in other parts of the world? What is globally accepted? I'm going to focus on North America, which is where high-rise buildings became very popular before Asia now took over, and they seem to have a lot more of those buildings. Now, in North America, in defining globally accepted design and planning standards, we cannot but ultimately do it in a manner that we relate them to our local situation. So when we look at what happens in North America, we also have to compare it to what obtains in Nigeria. What is different? What are we doing differently? Why are we having all these issues, all this building collapses? As a result of, now, North America is probably the continent where high-rise buildings were made acceptable to the whole world, but it has also recorded the most mishaps and casualties from this building type. They've also had fires, they've had collapses, they've had terrorism, they've had loss of life. As a result of, and in order to prevent or reduce this unfortunate incident, they have developed several building codes that guide practically all requirements for the various elements of the construction of high-rise buildings. So there are codes for almost everything. use and occupancy, the site setup, pedestrian safety, building heights, fire, smoke, type of construction, and so on, many more. Plumbing, elevators, the steel, the materials, the roof structure. Everything has a code that must be met. And the process for approval is pretty straightforward as well. So you have all this code that you must have. There's a document that tells you what is required. This document is very familiar. A lot of the consultants who are involved are very familiar with this document. They are conversant with what needs to be done. Now, what is the process abroad? The drawings and documents are prepared and certified by consultants. The design process. The process of design and planning is made less cumbersome because there's information to be obtained. There are things you want a code, you can Google it, you can make a call, it's online, you can get it. And then the advancement of technology through new software makes the design now of high-rise buildings fairly easy. A lot of things have become standardized. For approvals, a registered architect or professional engineer, as the case may be, submits the plans and documents to the relevant department of the city for necessary approval. Now, this third aspect is very important. The contractor. Once the building approval is issued, that is an approval that you can actually build the structure, a licensed contractor is appointed. It is that licensed contractor who applies for a permit to build. So he will obtain a work permit to start construction work. Without that license, even when you have approval, a contractor cannot start work. It is important to know the requirements and role of the contractor in this context. The contractor for a high-rise building must be licensed by the state and will be the one who has issued a permit to construct. Then inspection. Upon commencement of the work, the contractor will invite various city inspectors to check and approve the various stages of the work. For specialization and efficiency, these inspectors are mostly professionals drawn from the private party. They're not necessarily city employers. Numerous inspections and special inspections by these officials from various specializations will occur during the course of the construction. So there might be an inspector, for instance, for foundations only. There might even be an inspector for steel work, an inspector for glazing. These are specializations that cannot all be under the city because they can't have people who have that much knowledge about all these aspects. These inspectors stringently check all compliance with the relevant codes and standards. Approvals to proceed are granted once the work is deemed satisfactory. Under no circumstance can the contractor proceed without this approval. All inspection records are signed, electronically documented, and archived. Now, what obtains in Nigeria on a regular basis, on a normal basis? We're talking about land use and demand on land. As mentioned earlier, increasing land values in cities and population growth have led to an increase in demand. Lagos, Nigeria is not any different. It's where high-rise neighborhoods have witnessed an increase in population and a significant rise in the rental value and cost of land. I mean, somebody was telling me some days ago that Banana Island, for instance, was 10 million from 2 decades ago. Now, they're probably talking about 600, 800 million per plot. You can then look at what that means. So the table below shows population growth of DI and employees. This is from the Lagos City Model Plan. In 1991, Victoria Land had 40,000 people. The projection for 2025 is about 1.7 million people. Ikoyi seems to follow the same kind of trend. Ikoyi used to be low density, quiet neighborhood, but that seems to be changing. There's a new Lagos City, a new Lagos Model City Plan. There's one for Ikoyi and Victoria Land. There's also one for Ikeja. Those are considered urban centers in Lagos. There was a lot of frustration and pressure by landowners and developers on the state planning authorities to lift existing restrictions on height, which many developments had already begun to contravene. In a place like Ikoyi, I mean, there were people who felt, if I paid so much for this land, why should I just put 1 unit on it when I can put 6 units? So flats were starting to come up. Flats were starting to be built on a single family plot of land. In response to this changing demands and other future development objectives, Lagos State introduced a model city plan document for Ikoyi and Ikeja in 2013. And interestingly, and to the dislike of some parties, this new master plan changed the permissible heights for buildings in large segments of this neighborhood. High-rise developments of up to 110 meters or 30 floors are now allowed on some streets in Ikoyi and VI. This is a page from the new approval order from the model city plan. The recent building, the recent unfortunate incident that we had that occurred on Gerard Road. If you see from here, if you look at row 4, Gerard Road is now 110 meters permissible. Units per hectare is now 150 units per hectare. So that sort of tells you where we're going, what the future holds in terms of building heights in Nigeria. So in preparation for this master plan, Lagos State had a review. The Lagos State Assembly enacted a law in 2010 for the administration and regulation of fiscal planning. So they basically broke up the Ministry of Fiscal Planning, not broke it up, but they created new departments within that ministry. So they have the Lagos State Fiscal Planning Permit Authority. They're actually the ones that issue building permits to intending developers. Then the Lagos State Building Control Agency. Anybody who is in construction, in the building industry would have heard of LABSCA. They are very popular. They have the authority to regulate, to enforce, regulate, and inspect buildings under construction. Now, see, the process is not different from North America. Drawings are prepared by registered building professionals for submission to LABSCA. All required documents are submitted and an assessment fee is calculated. The necessary payments are made. The town planning officer visits the site to confirm that the site is actually free and ready for construction, and it is what is shown on the survey. Now, once the drawings and inspections are agreed, an approval for a building permit is issued. In all this, there's no demand for the involvement of a licensed contractor. So you put in your drawing, you put in your application, everything is reviewed, and you're given a building permit. Now, there's no question of, okay, who is going to do the building? So that is left entirely to the owner of the property to invite supposedly, hopefully qualified contractors. Now, in North America, for instance, the building permits, differently from North America, the building permit process here also needs to be reviewed. Now sometimes it's vague, tedious, and cumbersome. It needs to be made easier. The main player in construction regulation is LABSCA, and they have started with duties as described below. The contractor is expected to notify LABSCA of their intention to commence construction. Now, the way it works is that once you have your building permit, you should notify LABSCA that we are about to start. Several times, this this expectation is not readily conveyed. Every key stage before concrete placement, so contractor should inform LABSCA of the intention to commence construction, one. At every key stage before concrete placement, where the agency will visit to inspect the placement of reinforcement bars. Then they should also be notified of the completion of the project. Then any significant plan changes to the approved design, strip test results, and tensile strength results for the reinforcement. Now, because the system is different here, the inspectors are salaried staff of the agency. there are delays in scheduling. There could be delays in scheduling inspection. There are manpower shortages, and also the delays could also come from the contractor, who either doesn't understand the process or has not given adequate time. A considerable bit of work is required to make the process more streamlined and more effective. Current methods of enforcement of planning regulations are generally not deemed as purposeful or corrective. So you have your building, they've come to mark your building, and you start to question why they're there. You're not even sure why they're there. And oftentimes, when people see that the building has been sealed, it's revenue generation. Gladly, in recent times, the Federal Fire Service has also been involved in certification of buildings above 2 floors. But this involvement still needs to be clearly defined and better harmonized with state planning regulation processes. This is the Federal Fire Service, not the State Fire Service. How well are they working with Lagos State? Are people notified or informed of this requirement when they put in their application to Lagos State? Now, Mr. Ige spoke about something, about regulations, about codes, building codes. One of the major challenges we have right now is that there is a lack of an updated and approved national building code. There are several editions, but there's not one yet that has been approved by the National Assembly. This should contain all the necessary codes that will guide the building industry in Nigeria. Now, in conclusion, the question I would ask is, what can we do better? Some of the differences in the standards adopted have been mentioned earlier, but there are things that we need to improve upon, and this needs to be done urgently. There's a lack of knowledge by the general public of what is required. Continually educating the public of what is expected and the possible consequences of not engaging qualified professionals for projects. Regular town hall sessions are a very impactful means of achieving this. Providing ease of access to all necessary planning guidelines for the process of obtaining building development permits. Electronic means of sharing information and data will make the world of difference. A few years ago, Lagos State created an electronic application portal for online approval applications. But oftentimes, there are technical glitches, so people now end up taking their manual applications for submission. When the rules are clearly defined, they will become easier to adhere to. Making the process more streamlined, where documentation is better shared between oversight agencies. Developments that are compliant are sometimes marked for contravention because the approved documents were not passed or shared to the enforcing unit. So I've seen situations where one agency is not even aware that you're on site, or they're not even aware that this building has gotten planning approval. We must also create a system of licensing all contractors and ensuring that permits to build high-rise buildings and other large buildings are only issued to licensed contractors. Construction should not be accidents waiting to happen due to incompetence. Empowerment of the building industry professional bodies to ensure that only registered members of these bodies can and should oversee such developments as described. And there should be periodic interface between the building industry professional bodies and the regulatory agency. There are several proposals that have been put forward. Approval means that were introduced, but they were not followed. Things are still done before this. And there's a slight disconnect between the professional industry and the agency. The urgent approval of a new national building code that will become a guidebook for all building development. Enlarging the building construction regulatory and inspection agencies by engaging experienced private sector professionals as part of the mandatory inspection process. This should make the process more robust and building more effectiveness into the process. Ensuring that all stages of the construction work for all buildings, especially high-rise and tall buildings, are seriously inspected for from start to completion. This will be from the pile foundations done, for instance, right to the roof elements. It's not just to walk into a site and sign a paper, but everything should be checked. What is the concrete needs? What is your, what was your pile load test result? Did somebody witness the pile load test? Making the entire approval to inspection process be more purposeful with care intention. Oftentimes, a building that has been sealed for an obvious conservation is seen to be unsealed without the removal of the conservation. This is very common in Lagos. There are buildings that have not observed the required setback. It is glaring, it is obvious to everybody. The building is sealed, possibly for that purpose. And in a couple of weeks, the construction resumes, and that conservation hasn't been seen to have been put right. This may encourage belief that rules can be bent to one's purpose. There's certainly a lot more that can be said today regarding design and planning standards that are applied globally and locally. But I want to believe that we have managed to touch on the key factors that are considered in the process. Thank you very much.
Thank you very much, Architect Olumide Odukale. Thank you for those valuable suggestions as well. I can see some feedback in the chat, people saying and resonating, that your points are resonating with them. So thank you for that. Just as a reminder, this is being streamed on our social media platforms on First View YouTube channel, Facebook, as well as other social media platforms. And this is brought to you by the Nigerian British Infrastructure Group, a subset of the Nigerian British Business Forum based here in the UK. I would like to invite our lead architect within the Nigerian British Business Infrastructure Group and one of our second to the last speaker for today. I want to also appreciate those people who have been on. I've seen a total of well over 100 people that have been in and out of the room. Thank you so much for joining. And for those who have stayed with us so far, thank you very much for staying with us. We really appreciate the time you've taken out on a Saturday to be with us. So without further ado, I would like to invite Engineer Dapo Sulu, who attended the International School Ibadan and graduated from Ahmadu Bello University in 1983 with a bachelor's honors in civil engineering, postgraduate diploma in 1992, and MSc in geomaterials in 1995 from Queen Mary University, University of London. Is a chartered engineer and environmental manager, and currently practices as an engineering consultant in UK and West Africa. As previously mentioned, he is the lead architect within the Nigerian British Business Infrastructure Group. Please help me welcome Engineer Dapo Sulu. Thank you very much. And Architect Odukale, do you mind stop sharing as well, please? Thank you. Engineer Dapo Sulu, over to you, sir.
Hello, good afternoon, everyone. Greetings to all who have taken time out of their busy schedules to attend today's meeting. It's greatly appreciated. I'll just give a brief rundown of my topic. And my topic is, what are the environmental factors that affect high-rise building projects? Just to give you a background on me and my career so far, I am a civil engineer, chartered engineer, and I've worked in various phases of projects and with various companies as civil engineer. And currently I specialize in environmental management. So I'll just give you a brief rundown on some of the factors which I think should be considered when one is undertaking high-rise building projects. Designing a sustainable tall building requires a total view of the entire building enterprise, considering the local and global environment, availability of renewable and non-renewable resources, a decent community impact assessment, and the collaborative input of architects, engineers, planners, social scientists, and other community-based groups. Now, the life cycle of a typical structure involves the following stages: planning, design, construction, operation, maintenance, renovation, and finally be positively affected by environmental factors. There are several ways in which a building can be affected positively or negatively by sustainable procedures and processes. Such procedures are focused on the environmental efficiencies of the structures and include the manufacturing of recycled materials, structure erection methods, together with buildings' overall operations. In the current era, climate change, air pollution, depletion of biodiversity, and deterioration of the urban environment have become global issues. Accordingly, the construction industry is continually seeking new and innovative ways of creating more affordable, efficient, functional, and sustainable materials within high-rise construction. Currently, the most prominent trend within the high-rise industry is the utilization of existing energy through sustainable design means. High-rise structures use energy across their entire life cycle, from construction to demolition, as I just mentioned. So there is an increasing trend, investing in building energy efficiency, or what we call zero energy design. These innovations aim to further improve energy efficiency, together with creating increased productivity in buildings, reduction in construction impact on the surrounding environment, improved building efficiency, also have a positive impact upon project site, energy and water usage, materials and resource conservation, and improve the overall indoor environmental quality. Environmental factors can positively influence high-rise construction in 5 areas. The sustainable constructability includes all the planning, design, construction, operation, maintenance, renovation, and demolition stages. Structural performance specifically deals with the load-bearing integrity of the structure. You have innovation and design process, which deals with pioneering modeling techniques and procedures. Sustainable maintenance includes various preservation methods which further prolong a structure's life. And finally, the materials and resource effect, and also take into account the recyclability, environmentally friendly and conservational aspects of green structures. A full integration of engineering and is crucial. I mean, as mentioned by some of the previous work on high-rise building, and if we all put our heads together and effectively plan these buildings, they end up becoming more efficient. I mean, a well-integrated high-performance building may incur slightly higher initial costs than a regular one, but these costs may be offset by much lower operating costs. For example, the facade of a building usually covers up to 90% of the external building surface of a tall building. So the choices made in designing the facade have a massive impact upon energy gain or loss. For example, you look at the tallest building in the world, that's the Burj Khalifa in Abu Dhabi. Now, that building is probably, I think, 828 meters tall, if I'm not mistaken. And the facade employs a special type of glass. Now, obviously, it's built in desert areas where heat is a significant factor upon the area. So a special form of glass was designed which actually blots out ultraviolet light to a certain extent. As a result of this, initial cost of the glass is probably higher than would normally have been the case. But because the temperatures in the building are much lower than would otherwise be the case, therefore the maintenance costs of ventilation of the building are much lower. And that's where the savings come in. Harnessing solar energy. We have passive solar energy, which includes direct to indirect space heating, daylighting, and so on and so forth, and active solar energy, which involves technical installations such as solar collectors and photovoltaic panels. If a building, let's consider typical high-rise building in, let's say, a place like Nigeria. They tend to use large generators. These generators initially may be a lot cheaper than installing solar panels and other renewable energies. However, the maintenance costs and running costs of these this equipment tends to increase with time, and also due to the increase in and improvement in technology, the cost of solar energy installations is decreasing. So therefore, there comes a time where the cost of installing and using generators and other such equipment may become much more expensive than actually designing and installing solar energy panels, for example. That's something we can consider. Also, harnessing wind energy. Tall buildings can be shaped to funnel wind into a zone which contains wind turbines that can be used to increase the available energy and can be used for either heating or cooling. Some of the other issues involved in tall buildings include combined heat and power. In some of the more temperate areas of the world, there's a combination. Heat and power systems are combined, and they do tend to lead to low overall costs. There's also the use of fuel cells, biomass technology, geothermal energy, that's hot water from springs, and these tend to reduce the overall running cost of high-rise buildings. There are other issues, which potential toxicity of materials being used and things of this nature. We all know that in tall buildings, one of the major issues is ventilation. And if a tall building is not properly designed, there could be problems with indoor air quality. So therefore, these environmental factors need to be considered during the design of a tall building. Moving on, finally, there are a few questions which should be asked by anyone who is involved in the design of a tall building. For example, what kind of site will the project be built on? Is it going to be a greenfield site where nothing has been built before, or on a brownfield site where maybe buildings were demolished? That is going to significantly affect the foundations and below ground requirements. I mean, some of the previous speakers have mentioned about piling and piling foundations. These are things that need to be considered during the life cycle of a project. And there are environmental concerns which could be brought into bear in this respect. So these are things that need to be considered. If you have high-rise buildings, your foundations have to be up to spec. This will also depend on the kind of ground you're building in. If you're building on rock, your foundations may not need to be as robust as if you're building in soft or wet ground, or near a coastline where could be proximity to waterlogged ground. The area that you're building in, if it's subject to earthquakes, sinkholes, or subsidence, that could have a massive impact upon, once again, foundation works. Obviously, some of the previous speakers have mentioned about piling, about foundations, about things of this nature. These are things that need to be considered. How will electricity, water, and sewage services to the buildings be supplied and managed? It is a significant endeavor to get to a high building, something of 10, 15, 20 stories. these are things that need to be considered. Also, average ambient temperature. A 12-story building in Abuja will probably need to have different set of, need to be built in a different way and have different factors compared to the same building built in Alaska or London, for example. One needs to consider wind loading, ambient temperature, sunlight levels, and so on and so forth. So also something which is very significant is also during the construction phase, a lot of concrete is used on these various buildings. One needs to bear in mind that concrete needs to set and cure, and the periods over which concrete needs to set and cure differs between the various areas within which one carries out one's construction. Obviously, the concrete will probably take a different time to cure, maybe in somewhere like Abuja compared to Lagos or Alaska. These are things that we need to be considered, and the environmental aspects of the construction that need to be borne in mind. Finally, as mentioned by the previous speaker, what's the various rules and regulations in terms of building regulation and planning permission? These do need to be borne in mind. For example, during my career to date, I worked with various environmental organizations. I worked on a project once whereby we had to actually delay the start of a scheme for 6 months because there are certain wildlife which gain access to our site. For example, in Britain, there are environmental regulations which permit the movement of nesting birds or protected species, and these are strictly enforced. We worked on a project whereby we had, I think it was newts and bats got into an excavation which we carried out. And because of the rules and regulations in Britain, we could not touch these things, and we had to put the project back 6 months. These are rules and regulations which had to be strictly enforced and strictly adhered to by the contractors with whom I worked then. It's when countries have strict regulations in terms of whether environmental, building control, planning, and so on and so forth. When these rules and regulations are followed and adhered to, then within those rules and regulations, then that is when the development and production of buildings tends to be most efficient, and that way there seems to be fewer incidences like the unfortunate ones which tend to happen in Nigeria. So by and large, I think we're going the right direction, but we need to always ensure that all the rules and regulations which are in place are strictly followed. That way we end up with best practice, and the buildings we actually build tend to be the best that way. Thank you.
Thank you very much, Engineer Dakwasulu. I don't know if you can hear me. Your screen froze towards the end of that, but thank you for that insight as well. I looked through the messages and noticed that there was a question about the outcome of this presentations and if it will be presented to the federal government and the state government, especially the Lagos state government. I can confirm that we will be putting out a communique which will be going directly to the Vice President as well as stakeholders within the Lagos state government moving forward. So we have a last speaker. He's going to be wrapping up this session, and then hopefully we have a couple of minutes to take a few questions. But if we don't have the opportunity to take questions, please do reach out to us directly on our social media platforms. You can reach us on Nigerian British Business Forum. We're on Instagram, Facebook, and you can also reach us on the First View TV on YouTube, the YouTube channel First View TV. So I would like to invite at this point Engineer Tomi Adebayo. Engineer Tomi Adebayo is a civil structural engineer as well as a building control consultant based in the UK. With over 35 years experience, he practiced in Nigeria in his early career and then moved to the UK. Engineer Tomi was a principal structural engineer in local government building control for 15 years and now runs a firm that provides structural engineering support to building control approved inspector firms. He will be contributing mainly to the possible regulatory practices that would reduce the risk of collapse in buildings generally and specifically for high-rise structures. I'd like to welcome Engineer Tomi Adebayo.
Good afternoon, ladies and gentlemen. It's rather ironic that building control is the last speaker today. But meanwhile, if anything goes wrong, building control are one of the first in the firing line. As you can see, what happened to one of our colleagues in Lagos State when this thing went wrong. My sister did say, "Why are you the last speaker?" I said, "I don't know." Building control is probably a rather boring topic, but building control is your friend. We are here to protect you from all sorts of things that you don't really understand. Now, in my words, building control is the process of ensuring that construction work is done to a national standard, starting from the design stage and right through to completion on site. A lot of people do not understand the difference between building control and town planning. Town planners are things to do with zoning, what can be built in a particular area, and where a building is supposed to be located, and what that building is used for. Building control are those people that are more technical people that make sure that things are done in the right way and to a particular standard. Nigeria does have a national building code, but that building code probably needs to be worked on in terms of it needs to have some supporting supplementary guides that can apply locally in different areas. Something that applies in Ikoyi will not apply in Abuja, will not apply in Ibadan, and will not apply in some other parts of Nigeria. So those documents need to be sort of supplemented. I've gone through the National Building Code. I wouldn't say it is deficient, and I think it probably needs to be enacted because it's not enforceable by law. Now, some of us have gone through various definitions of a high-rise, and it does vary from country to country, but I think it should be related to the capacity of the fire authority in each country. In a country, Nigeria, where I don't want to say anything negative about the fire authority right now, but I can say that it's not quite as advanced as you would expect in probably North America. So if we are building 100-story buildings, 200-story buildings, you need to bear in mind that we are going to have challenges if there is a fire on the 45th floor, and how are we going to deal with that? So in my opinion, now, these are the processes of building control. There are processes that have to happen before construction. Before construction, Wale Ogundalu has mentioned some things, Engineer Ige has mentioned some things in having the architect's drawing, in having town planners, QSs, and all these people are involved before this thing comes to building control. The architect produces a detailed plan. The architect thinks of how people are going to get out of the building in the case of a fire. Let's move to the next slide. Now, after the architect has done all his nice looking drawings and it looks pretty and is well presented, which attracts end users to want to buy these things, then the structural engineer has to see how this building is going to be built safely, how it's going to remain under all sorts of loading, just like Wale has said, columns, pillars, beams, lift shafts, roofs. Somebody has to make sure that all these things are strong enough to withstand all the loads. When we talk about dead loads, we're talking about the actual load of concrete, of the structure, the actual weight of the structure. And when we're talking about live loads, we're talking about things like people that are going to be in there in the final analysis. Now, what happens is, just like you've all said, when you're talking about specialists, the problem with building control is that all these specialist drawings are sent to a building control section. And when they're sent to the building control section, do they actually have the skills to check these plans? Do they have the skills? If I'm talking about finance elements method to a building control officer in Lagos State, does he really know what I'm talking about? If I'm talking about piling, I'm talking about second piles, ground piles, all sorts of piles, does he really know? I can see architect Odukale said something about private sector involvement, because you do need these sort of people, because these things are beyond the skill of the day-to-day building control officer anywhere in the world. In UK now, we have approved inspectors that are actually in the private sector and are regulated by a national body. Let's move on. Now, during construction, you also have inspectors from building control that should have copies of the approved plans with them. So they have a copy of the plans. Like, okay, Mr. Engineer Ogundalu has said, this foundation is supposed to be this deep. This column is supposed to be 300 by 400. The reinforcement is supposed to be 20 millimeter at 200 centers. And that is what he's got in front of him. Yeah, and that is what he's supposed to be checking. Now, when you're talking about specialist things, particularly high-rise, there are some things that could be beyond the skill of a standard building control officer. If you're looking at connections, if you're looking at, as I said, steel reinforcements, some of it are very complicated. What steel needs to be at the top? What still needs to be at the bottom? What are the shear links? All sorts of things that in some countries, like probably in UK, a structural engineer goes out to do the structural checks, and then you bring in all sorts of consultant building control officers to look at other things. Now, after construction, Lady Udo mentioned something about due diligence, and that is because sometimes a building or a flat needs to be sold. You want to buy a flat, and you want to know that that flat you paid $1.2 million for has actually been checked. It has been audited by somebody, and there is a sort of certificate that you can use in future to say there is some sort of assurance that this thing has been done properly. You might have to take out an insurance to insure the property against fire, against different things. And those are where having a completion certificate shows that at least a level of assurance has been adopted in this property. You have to have a situation where you have as-built drawings, so you can refer back in future. Now, I use the word effective building control because building control cannot be effective if the officers are not qualified and experienced in high-rise design and construction. Yet again, that can be helped with the private sector. You have to have building control officers that have legal powers. So, like architect mentioned, the National Building Code is not enacted. In UK, the building regulation has an act, the town planning have an act, and they can lock you up, they can do all sorts of things, they can seize you, they can freeze your accounts, they can, anything they can do when you don't follow the law. They must have reasonable access. That means you can't just lock out a building control officer and say, you are not coming here. We saw some ugly incidents in Ikoyi. You never know with social media whether that is correct, but it seems like they were refused access to the sites. That is not really good. Now, we must not ignore the elephant in the room, which is corruption. Yeah. And this happens anywhere in the world. It's not just Nigeria. And there have to be some methods, some checks and balances in which we can use to make sure that these building control officers are of high integrity and they are fair. They're not just going to people's sites and locking them down for some other reason, which I would not mention, but we all know the sort of reasons that some of these guys will come around and just generally just lock you down. Building control officers must have safety equipment because they're working in a high-risk area. You can imagine you work on a high-risk structure and somebody drops a bolt from 20 floors and it lands on your head. You're not going to survive that. Building control officers must be able to take records on site, and those records have to be saved safely. So not just paper records, those records have to be on a computer, because in future we might have to refer to those records. Now, what are the problems that building control face? One of the problems they face is, yes, they lack adequate enforcement. In fact, they lack any enforcement powers in some cases. I think some states probably don't even have building control. I think this unfortunate incident has focused our minds on building control in a way that we didn't. Condolences that some people lost their lives and this happened, but in every cloud there is a silver lining, and this might be an opportunity for us to really look at some of these things and really make sure that this sort of situation, which is almost an embarrassment to the country, doesn't happen again. Now, software, like we said, somebody has designed a very complicated multi-rise structure with thousands of pages and has just dumped it in front of a building control officer who doesn't have the software, he doesn't have the skill to check them. So therefore, it is important again that we have equivalent people on the other side that are checking. In UK, just like Kayode has said, the developer himself has his own checking in-house checking. He's not relying. It doesn't matter that somebody has a PhD from Imperial College. It doesn't matter that he is a whiz kid. People make mistakes, omissions are made. Therefore, we should have an adequate and equivalent person checking sophisticated designs. Now, what we have in most of cases of these high-rise buildings, they are designed by top consulting structural engineers. But despite that, in the countries like UK, they will not say, okay, because it's been designed by Arup, there's nothing wrong with it. They're experts. They know exactly what they're doing. So if the Arup says it's good, it's good. No, they will find a company of the same caliber as Arup to check it. They mentioned a company called IIS in Nigeria, who is run by an engineer, Akintilo. And I found that, yes, this is somebody of very high caliber. Now, we need to also set minimum standards for these structural engineers, yes, not just being a membership of COREN, because COREN encompasses a lot of engineers. I remember when I was a youngish engineer in the beginning of my career, I had my senior manager used to stamp my calculations when we were going to take them to the town planning, and he was an electrical engineer. He had this nice stamp, and he would just stamp it, and he would just look at me and said, "Are you confident this is okay?" I said, "Yeah, of course it's okay." And he will stamp it. So we probably need to be a bit more specialist in saying not just qualified engineer, they have to be qualified in this narrow field of high-rise structures, not just any engineer. And that cannot effectively be done by building control. In this country, most developments are financed, and the finance company will do their own due diligence. They will ask to see who is going to be the engineer for this project. They will look at them and say, you know, what is your turnover? Have you done this before? This, and that. And what they will do, they'll just put an astronomical insurance fee on the job to say, look, we don't know these guys. They're not competent. And then the developer will say, why? Oh, because, you know, this guy you put in front of us, we don't think is up to the job. So, but in Nigeria, I don't think we have that. So now we have to, when we have building control, they have to have specific teams. They have to have a sort of high-rise team that deals with high-rise structures. So you don't just send any of the building control guys. You have a team of specialized building control officers. And if you don't, then we need to go again to the private sector. So I might be overselling this private sector thing, but I think that because of the level of influence on local government and state building control in an environment like Lagos, where they have all sorts of political influence, it is not that easy for them to be able to do their job in a fair environment. And when we do empower these building control officers, it is also possible for them to abuse the power, because now we've empowered them. Now they're going around locking up everybody's sites, knocking down everybody's buildings, which I think probably they've started to do, which I think is an over knee-jerk reaction. We shouldn't really be doing that. We should, like I said, have supplementary documents to buttress the building code, so that it makes it easier for the building control officers that are not specialists in something. Just guidelines like Ikoyi, Victoria Island, we expect the foundations to be pilot foundations. Now, in order to help develop building control, we should have a lot more training. I think Kay also mentioned something about education. We have to educate these people. We have to invite them to seminars. We have to have open webinars where people will talk on a specific aspect that helps people with to gain that knowledge on high-rise. Now, we've emphasized so much on the structural aspect, but it's very, very important. There are two very critical parts of what we call the approved documents in the United Kingdom, which are supplements to the building regulations. And in the approved documents, the part A of the approved documents deals with structural, because structural is probably the most important. And then part B deals with fire. It is very important that you have a fire on a 40, 50-story building. You don't even have fire brigade access to where the building is burning. You know, that's just disaster. Minimum qualifications for the building control, diplomas, degrees, past experience. Somebody has to set up a framework where we expect that a building control officer has a sort of minimum qualification. But most importantly, that person has to be very willing to learn, because building control is live and it changes all the time. Now, state governments should, as if they don't have the powers to lock people up, I think one thing they could do is shame them. You know, just like they used to do in the olden days. So is no longer a member of our company. We sacked him and don't do any business with this person anymore. So Lagos State government should say this building is not safe, and anyone that purchases or occupies this building does so at their own risk. I think if one or two developers have that stamped in a national newspaper, I think a lot of them will probably start to behave themselves. Now, a national health and safety body. That is going to take a long time to implement. We have been having high-rise buildings in Nigeria. The first one I was involved in was 1983. Eagle House is still standing there. So this unfortunate incident was a one-off, but we should at one stage have an enforcement body that has serious powers. Like I said, the Health and Safety Executive in UK can freeze your account, they can suspend you as a company director, they can actually make you have a criminal record, which can ruin your career. So these people have very serious powers. We should also have a situation of where we could have a whistleblowing website where you can actually go and as a member of public just show, or as an engineer that's seeing something that is not, and just send an email to Coren to say something bad is happening there. Now, if we now look at the recent disaster, what people have been blaming the structural engineers, but the structural engineers designed something for 6 floors, and that 6th floor went to 8, 10, and ended up as 21. No matter how much factor of safety the structural engineers could have put into that structure eventually had to obey the law of gravity and come down. Now, if building control had more powers, probably. It's all about risk management. Yeah, these things could have been, the risk could have been reduced. So everything that's happening within high rise is layers of safety. In UK, you have 4, 5, 6. You have CDM, like Kay mentioned. If CDM will pick up who is the engineer, who is the architect, straight away, no, we can't have Mr. Blah, blah, blah as architect. He only left uni 2 years ago. We have to have them to have specific experience, train them, even if we have to send them abroad to go and shadow. Let's hope they come back if we do send them abroad. But if we do send them abroad, to Dubai, to India, to Chicago, just to see how things happen so that they can come back and pick up some international standards. Yes, again, I say third-party private sector engineers anywhere in the world is very difficult to have a local in-house building control that can deal with sophisticated buildings such as high-rise. They have to be supported by the private sector. It is just one of those things. There are some things that that I probably haven't been able to mention, but thank you, and I'll just expect questions from the members of those people that have taken out their time to attend. Thank you very much. Bye.
Thank you very much, Engineer Tomi Adebayo. There were some questions around the gaps between the UK, US, and other parts of the world versus Nigeria, but I think you've touched on some of it in your presentation around the building controls, and that's so insightful. Thank you very much. Now, I'm conscious of time. We are over time. We're 15 minutes over time at this point, but I think there's a question here, and this would, on the hot topic of the Ikoyi collapse, that I think it will be good to just briefly touch on. And if we can have every speaker just provide some sort of insight based on their own professional experience, and make sure you also touch on the regulations, if there were any sort of regulatory blunders that were existent in the present investigation. We know that it's still ongoing. It's still an ongoing investigation, but it's key. There's a question here that says, was the Ikoyi collapse a failure of building control or corruption in the system, or even both? How an 8-story building ended up with 21 floors is a mystery for a lot of people. So I think it will be good to have architect Olumide just quickly from his own standpoint, what are your thoughts around that question? Is this a mixture of corruption or building control, or singularly building control? So if we start with engineer architect Okale. Yes, sir.
Thanks again. Because there's a panel of inquiry ongoing at the sitting, I think we should be mindful of expressing opinions, professional opinions on this matter. It is very unfortunate, but what I would say, I cannot say whether there were oversight failures on behalf of the regulatory body, and I can't say whether it was a structural failure. For now, I mean, immediately a building like that comes down, the first thing that comes to mind is, the structure has failed. If you watch the first video that came on air on social media, there were comments by people there, oh, look at, see the iron with them use, so everybody becomes an expert. Now, again, we need to have regulation, and we need to have a system whereby not everybody who is a developer becomes a builder. In this particular instance, what was said is that the project signboard did not have any known names as consultants. It was just phone numbers. That shouldn't have been able to fly. So, I mean, it's little things like that that may suggest that there was a failure in regulation and in oversight.
Thank you. Mr. Zudo Konjo, you run an organization that is based in Ikoyi, and you've done quite a lot of high-rise buildings in Ikoyi specifically as well. What are your thoughts around that collapse, and your thoughts in general?
Thank you, Sean. I mean, obviously there's an investigation, and we will have to let it run its course. I will speak more from the perspective of if I was representing a buyer, or, asking those questions about the 5 Ws once again. If investors had asked the question, who are the contractors? Mr. Adebayo was talking about specialization. So clearly, when you're building a 20-story tower or building, we're talking specialists, contributors, stakeholders, builders, all of that. So on the face of it, it appears that was not the case in this particular project. But we'll have to wait, to see all of that. My key concern, however, is from the commercial and financial side. We have to remember that there are people who have invested in those properties, that are no longer there. Insurance, contracts, there are people who supplied, so really what we're talking here is really about, standards and all around. So on the government side, regulatory oversight, all of that stuff, it is glaring, it is clear. We can't speak to those who have actually done the work, but certainly from the government side of things, we cannot ignore what is obvious.
Absolutely, we cannot ignore what is obvious. There were some writings on the wall that were clearly out there that shouldn't have been ignored. Thank you very much. Engineer Ogundalu, this question is to you. if you had a magic wand, if you could do abracadabra and everything works well, Nigeria becomes the mecca of high-rise buildings, great architectural work. What would you do? What, in your own experience, would you do that could make that difference? Are there any sort of key pointers that you would want to put out there in your experience that could bring us to of great high-rise buildings as well?
Thank you very much. The first thing I will mention is that Nigerian engineers are good, they are great, and they have been designing, developing, supervising many high-rise buildings in Nigeria. And they are standing and they are perfect. I could give you an example of the Cocoa House that was done more than 30 or 40 years ago in Ibadan. It's still standing. I can also tell you that I, as a staff of Riverop and Partners, I designed so many high-rise buildings in Lagos. They are still standing. So I believe that we can do that. Now, the problem is, from my experience, when you are designing a structure is supposed to support dead load and live load. Dead load, probably you have, let's say, self-weight of the slab. If you are talking about a 150 slab, you are talking of a self-weight of 3.6, finishes about 1.2, that's 4.8. You multiply with a factor of safety of, say, 1.4, that's the code, and then the live load for residential is 1.5. You multiply with 1.6. So each of those loads have factors of safety. And the materials also have factors of safety. You underrate the strength of the material. You multiply with 0.8 or 0.75 or 0.67, depending on the code you are using. So each of those things have safety factors. As an engineer with Arup, I can tell you I supervised almost all the international contractors that you have in Nigeria. And those buildings are safe and they are sound. Now, when it comes to high-rise buildings, I'm sure that there are Nigerians that will handle this with no problem. Now, coming back to the issue of the collapsed building. One of my colleagues have already mentioned that you have the signpost, there is no name of any company on it. That is not good. Now, you do your design, structural drawings, you hand it over to the, to the agencies. It's stamped, no problem. When it comes to the construction, like I stated in my paper, you must have a resident engineer who is supervising that building right from foundation to completion. And what's the purpose? Is there to check that the contractor fixed the reinforcement as specified on the drawing. Once that is missing, and you cannot guarantee if the reinforcement was properly fixed, your building is not going to be stable. You cannot guarantee the stability of that structure. Now, when we started high-rise buildings, we had all those things in place. There is a design contract, there is a supervision contract, and you go there every time that you are needed. It's either you are there permanently or when the contractor has fixed his reinforcement and he wants to cast, he calls the company and the company sends a representative, and we go there and we visit it, and immediately you come back to the office, you write a site visit report. Now for the KOI collapse, do we have any site visit report? Do we have any paper by any engineer who satisfied each floor reinforcement till it got to where it is? That building is under dead load. Nobody is living inside it. For that building to come down, total collapse, there are so many things involved. So I don't know if I've answered your questions or not, but there are still more stories that will come out in respect of that. For example, in one of my projects, I was invited to come and look at a job. The cantilever had failed. It was already deflecting. And the client said, Wale, come and help me look at this job. What happened? And as soon as I got there, I said, look, it's either they didn't put reinforcement in this cantilever or it was wrongly placed. And they said it was checked. I said, who checked it? And they pointed to a man. I said, are you an engineer? He said, no. Then what are you? He said, he's an architect. And I told him point blank, I said, you are not qualified to inspect and approve this reinforcement. Oh, he said he was taught in school and he felt he could do it. I said, well, if you approved it, I'm sure they didn't put reinforcement. He said they put it. I said, then they put it wrongly. So when the argument was getting tough, I said, don't worry, we don't need to argue about this. Just get me a worker, let him chisel the top 25 mm over a box. I just drew a box, 300 by 300. I said, chisel it 25 mm. They chisel it 25 mm because the cover is supposed to be 25 mm. They chisel it 25 mm, and there was no reinforcement. I said, go ahead to another 50 mm. They chiseled, there was no reinforcement. I said, so they didn't put it. He said, but he saw it. I said, they put it wrongly. For a cantilever, the reinforcement is supposed to be at the top and then goes over the cantilever and then returns back. But what did they do? They put it on the floor, on the bottom, then they turn it up, and by the time they got to the line of the beam, they stopped it. And even though they put reinforcement, it was wrongly placed, it was not effective, and it's as if you didn't put any iron rod at all.
Thank you very much, Engineer Ogundalo. That was a very relevant case study. I am conscious of time. There are some appointments in the next 3 minutes that some people have messaged saying that they have to run to. Please, if you have any questions, we still would like to solicit your questions. We are on WhatsApp as well. So the Nigerian British Business Forum is on WhatsApp. We're available via email, and our speakers will be available to answer your questions. So please send an email to info@nbbf.co.uk or info@nbigroup.co.uk. If there are any pointers that you would like us to highlight in the communique, which will be going to the federal government as well as the state government, please endeavor to highlight that in there. We'll be gathering the information from our speakers, some of the pointers that they've given, especially around regulations. We'll be putting that together as well as part of our communique. We want to thank you. I personally want to thank all the speakers. I've learned a lot. I don't have the money yet for a high-rise building, but I almost feel like I can go into one right now as a financier because I've already gotten all the must-dos and the do-nots that is needed. If there any way that we would, anyone on the call would like to contact the speakers, please reach out to us as well. They're available for any projects or any consultation work that you might need as well. Ladies and gentlemen, my name is Sean David Onomasi. It's been an absolute pleasure spending this morning / early afternoon with you all. Thank you to all our speakers and thank you to everyone that has joined. Till the next time, we do wish you a beautiful rest of the day and a beautiful weekend. Thank you very much, everyone. Thank you.
Let us usher you into the world of CBAR Technologies. At CBAR Technologies, we cater for all your salient digital and technological needs, such as web and app development, domains and hosting, web security services, broadcast streaming, and a host of other exciting technological features. For further information, why not visit us at www.cbartechnologies.com. CBAR Technologies, redefining the art of digital technology.